Hi children, this is the fourth video of the topic differentiation. In this topic, mainly we are going to focus our knowledge about tangents and normals. What do you mean by a tangent? In certain places, it mentioned that tangent is a straight line which intersects the curve only at one point. But it's a myth. If you consider any tangent, there may be chances where the tangent may meet the curve not only at one point. Sometimes there may be few points. But special cases like a circle. If you draw a tangent to a circle, there is only one point. Then what is a tangent? Tangent is a straight line which has the same gradient as the curve where it's already drawn. When you try to identify the equation of a tangent, we need to concern about two special properties of a tangent. The first property is, if you consider the gradient of a tangent and if you consider the gradient of the curve, both become similar to each other. The second property is, if you draw a tangent to a curve, both the tangent and the curve passes to the same point, that is called the tangent point. Let's try to find the equation of a tangent using one example. The question is, find the equation of the tangent drawn to y equals to x squared plus 5x minus 3 at a point A, 1, 3. How to find this answer? Mainly, as I mentioned in the previous slide, to find the equation of a tangent, we use two properties. First property is gradient of the curve and gradient of the tangent both are equal. Therefore, if we find the gradient of the curve, there you can find the gradient of the tangent as well. How to find the gradient of a curve? The simple theory is, to identify the gradient of a curve, we need to find the differentiation. First, find the first differentiation of y equals to x squared plus 5x minus 3. The first differentiation is 2x plus 5. Then, to find the gradient, we need to substitute the coordinate into that point. We know that first differentiation is a function of x. Therefore, let's substitute the x coordinate 1 into first differentiation. If you substitute 1, you receive the answer 7. That means the gradient of the curve is 7. From the theory, gradient of the curve and gradient of the tangent are similar. We can say that gradient of the tangent also 7. Now we know the gradient of the tangent is 7 and we need another coordinate to find the equation of the tangent. We know that both tangent and the curve travels to the coordinate a, 1, 3. Therefore, we can use the formula y minus y naught equals to gradient times of x minus x naught, whereas m would be the gradient, x naught, y naught would be the coordinate a, 1, 3. If you substitute into that, you can get the equation of the tangent. Let's try to verify the theory from another example. The question is, find the equation of tangent drawn to y equals to 2x cubed minus 4x squared plus 5x minus 3 at x equals to 2. There is a slight difference than the previous question. In the previous question, they have given the full coordinate, but here they have given only the x coordinate. As mentioned in the previous slide, first we need to differentiate. If you differentiate y equals to 2x cubed minus 4x squared plus 5x minus 3, you receive the answer 3x squared minus 8x plus 5. Then if you substitute the x coordinate, you receive the answer 1. That means gradient of the curve at x equals to 2 is 1. From the previous theory, we know that gradient of the curve is similar to gradient of the tangent. Therefore, gradient of the tangent become 1. We know the gradient right now. Apart from the gradient, we need one coordinate to find the equation of the tangent. How to find the coordinate? We know that x coordinate is 2 in this question. Then if you substitute x equals to 2 into y equals to 2x cube minus 4x squared plus 5x minus 3, you should receive the y coordinate. Then when you substitute x equals to 2 into equation, you receive the y coordinate at minus 1. That means the coordinate of the curve where x equals to 2 should be 2 minus 1. We know that the tangent and the curve both traverse the same point, therefore the curve should be passed through 2 minus 1 as well as the tangent. Now if you substitute the coordinate 2 minus 1 and the gradient 1 into the equation y minus y naught equals to gradient times of x minus x naught, you should receive the answer y equals to x minus 3. Then that would be the equation of the tangent. Now let's try to study about a normal. Normal is a straight line which is perpendicular to the curve at the given point. To find the equation of a normal, we should know two properties of a normal. The first property is, since the normal is perpendicular to the curve, if you get the gradient of the curve and if you get the gradient of the normal, and if you multiply them, you should receive the answer as minus 1. It's a common theory about gradients between two straight lines perpendicular to each other. The second theory is both the normal and the curve travels to the same point, therefore it follows up the same coordinate. Now let's try to verify this theory from one example. The question is, find the equation of the normal drawn to y equals to x squared plus 5x minus 3 at point A 1 3. To find the gradient of the normal, initially we need to find the gradient of the curve. To find the gradient of the curve, initially let's differentiate the curve. If you differentiate x squared plus 5x minus 3, you receive the answer 2x plus 5. Then if you substitute the x coordinate equals to 1 into this first differentiation form, you receive the answer as 7. Therefore, the gradient of the curve becomes 7. That is the gradient of the curve. From the previous slide, we know that the curve and the normal are perpendicular to each other. Therefore, if you multiply the gradient of the curve by gradient of the normal, you receive the answer as minus 1. From that relation, we can understand gradient of the normal become minus 1 over 7. Now we know the gradient of the normal is minus 1 over 7 and it travels to the coordinate a equals to 1 over 3. Therefore, if you substitute these figures into the equation of a straight line, y minus y naught equals to gradient times of x minus x naught, whereas m is the gradient and x naught y naught is the coordinate, you receive the answer y equals to minus 1 over 7x plus 22 over 7. Let's move to another example. The question is to find the equation of normal for y equals to 2x cubed minus 4x squared plus 5x minus 3 at x equals to 2. Initially, let's try to find the gradient of the curve. If you differentiate y equals to 2x cubed minus 4x squared plus 5x minus 3, you receive the answer 3x squared minus 8x plus 5. Then we need to find the gradient at x equals to 2. Therefore, we will substitute x equals to 2 into the first differentiation answer. That is 3x squared minus 8x plus 5. If you substitute into that, you receive the answer 1. Then that is the gradient of the curve. The curve and the normal are perpendicular to each other. Therefore, if you multiply their gradients, you receive the answer as minus 1. From that relationship, we realize that the gradient of the normal become minus 1. Now we know that The gradient of the normal is -1 and x-coordinate of the point of normal is 2. We need to find the y-coordinate as well. To find the y-coordinate, we have to substitute x equals to 2 into the main equation y equals to 2x squared minus 4x squared plus 5x minus 3. If you substitute that, you receive the answer y equals to -1. Therefore, the coordinate of the curve at x equals to 2 would be 2 comma -1, whereas which is exactly similar to the coordinate of the normal passes through. If you substitute this coordinate x equals to 2 and y equals to -1 and gradient equals to -1 into the equation y minus y naught equals to gradient times of x minus x naught, you can receive the answer y equals to minus x plus 1, whereas it's a equation of the normal drawn to curve at a 2 minus 1.